Hi everyone! This video will show you how to use the triangulation and filling holes features. Select the target point cloud, click the Edit tab, and select Triangulation. For confined spaces like the tunnel in this example, select Surface Triangular Mesh and set a value for the sampling interval. The smaller the value, the higher the accuracy. After generation, check only the model to view the effect. Here, we increase the sampling interval value to see the effect. After selecting the generated model, click the Edit tab and select Fill Holes. The default value 0 means filling all holes. You can also customize the maximum hole filling length. Click OK to view the effect. You can also perform smoothing for the model. Click Smooth to select the smoothness grade. Finally, you can sample the model. In the menu, there are two sampling methods, by percentage and by grid. Select percentage and set the sampling percentage to 80% here. You can also select grid for the sampling method. After setting, the point cloud will be optimized based on the set grid resolution. Now, let's compare the effects of the two methods. This is our introduction to the triangulation and filling holes features. See you next time. Hi everyone! This video will show you how to use the profile analysis feature. Select the point cloud file to be analyzed. Click Profile Analysis on the Start tab, and the vertical view is selected by default. Left-click to draw a section between 2 points of the point cloud, and right-click to finish and pop up the profile view. Select the measurement icon in the upper right corner, shown by default, to measure the required distance. Height, 17.237 meters. Width, 12.397 meters. Select the parallel view to cut the length and width of the section. Adjust the offset direction to either the Z or Y axis. You can also set the offset distance. Positive values indicate an upward offset. Negative values indicate a downward offset. The width means the thickness of the section. After all the settings are done, click OK to update the section display. Select Point Color to display the rendering color of the point cloud. You can measure multiple times with the measurement toolbar. If you don't need a data point, click to turn it red. Then, press the Delete key on the keyboard to delete it. After changing the rendering color under the Display toolbar, the point cloud color will also change in the profile view. Scroll the mouse to zoom in and out of the profile view. You can also measure the thickness of the point cloud. This is our introduction to the profile analysis feature. See you next time. Hi everyone! This video will show you how to use the sharing feature. After you select a point cloud, click Share in the upper right corner and a prompt will pop up, asking if you want to share it online. You can click OK to start uploading it. When the upload is done, the data will be processed on the back end. A prompt will pop up after the processing is done. You can click Copy URL to copy the link and paste it into your browser. Then, you can view the current point cloud. On the left toolbar, you can adjust the point cloud. You can also measure your point cloud with the toolbar below. This is our introduction to the sharing feature. See you next time. Hi everyone! This video will show you how to use the measurement tools. First, select the point cloud you want to measure, and click the measurement toolbar to pop up the measurement tools. The first one is point measurement. You can click any point to display its current information. The second one is length measurement. Left-click to select a length, and right-click to see how long it is. The third one is height measurement. Left-click to measure floor height, and right-click to see how high it is. The fourth one is angle measurement. You can measure angles and corners. The fifth one is area measurement. Select an area to measure. After selection, right-click to see how large it is. After clicking square root, you can see the currently saved measurement information under the Label tab. This is our introduction to the measurement feature. See you next time. Hi everyone. In this video, we'll walk you through the point cloud mapping feature. Before mapping, we need to create a new project. Enter the project name, select a path to save it, and then click OK to create the new project. Next, click the point cloud mapping feature. There are S1 and P1 for the device model. For S1, there are 4 scenarios: indoor, outdoor, vehicle, and tunnel. Here, we can also select a mapping range or change it. For P1, there are 2 scenarios: indoor and outdoor. We can also select the mapping range. Then, enter the advanced settings to set the mapping parameters and RTK offset. If the loop data is unclosed or layered after solving it, we can enable the back to starting point feature, and the dynamic object removal feature will be automatically enabled. Here, we have 3 offsets for the RTK receiver: deviation X, Y, and Z. When the position of RTK receiver is changed in vehicle or backpack mode, we need to edit this parameter with the offset values to ensure the accuracy of point cloud mapping. The last is to set camera parameters. When the camera parameters are recalibrated or not imported into the scanner, we must manually input them each time we create a map. After all the settings are done, we take P1 for the mapping demo. Click Next to enter the mapping page. First, select the FUDSLAM data file for mapping. As P1 carries data from an RTK camera for our demo, we need to enable RTK Fusion here. Below, we can choose the corresponding coordinate system. If there is no desired option, we can also choose Custom Coordinate System. Select the projection parameters in projection mode. Here, we can edit some parameters, including central meridian, origin latitude, false easting, false northing, and scale factor. We can also import converted parameters here or enter them manually. If we are in a known or standard geographic coordinate system, we can choose the standard system. The second case is that after we have completed data collection, we use the RTK survey software to convert the FJDRTK data and obtain the local target.FJDRTK data. Then we can directly select it here and import our target.FJDRTK data at the same time. If we haven't converted the file in the survey software, we can directly select Custom Coordinate System. Once a standard coordinate system is selected, the corresponding FJDRTK data file will be read automatically. The third feature is Optimize with Control Point. In the case where we use the base station to collect some control points during scanning and obtain the geographic coordinates of these points, we can enter or import the file of these coordinate points in TXT or Excel format. Since both Optimize with Control Point and RTK Fusion will convert the coordinates to the geographic coordinate system, we can only select one of them to perform. As we use the RTK data, we enable RTK Fusion here. Next, import the data for point cloud colorization. We only need to import the 2.ins data files collected by the camera. If we have converted the files before, we can also directly import the converted .mp4 format file. Once the files are imported, click OK to create the point cloud. The screen will show the mapping progress. We can also click Display Frame by Frame or Cumulative Display to show the point cloud. Since we have obtained the colorized point cloud data in the absolute coordinate system, we can render it with various colors. Currently, it is in RGB mode, and we can change it to elevation mode, where we can display by time, intensity, or a combination of elevation and intensity. We can also display color point cloud data in the form of boundary reinforcement or X-ray. After the point cloud is mapped, we get the color data with absolute coordinate information. Hold down the Shift button and select a point. Then we will see the relative and absolute coordinates. We can also select the point cloud and see the coordinate information of the point cloud in the lower right corner. We can also operate RTK registrations separately. Here, choose the fjdRTK file or custom coordinate system. If the point cloud is not colorized during mapping, we can select the point cloud and colorize it here. In the advanced settings, we can also enter the camera parameter file. If the camera parameter file has already been imported into the scanner, then we don't need to enter it here. But if the file is changed, we need to import the change file here. This is our introduction to the point cloud mapping feature. We hope you have learned to use it. Hello everyone. Today I will explain to you how to use the XY transpose function in the FJD Trine Model 200 version. Due to the differences in the coordinate axes of the default coordinate systems used in different countries and regions, we have added the XY transposition function in the Model 200 version to quickly solve this problem. In the model software, it supports converting multiple point cloud files at the same time. You only need to select multiple points in the project file on the left. Here, one point cloud file is used for demonstration. After selecting the point cloud file to be converted, select the XY transpose function in the Start menu. When the transposition is completed, the converted point cloud will be added to the file tree on the left, and the original point cloud file will be retained. Switch to the top view and select two-point cloud data at the same time. We can find that the 2 point clouds before and after the conversion are axisymmetric. Now perform point selection tests on these 2 point clouds. We select a point in the original point cloud before conversion according to the scene. Then we find the point of the same scene in the new point cloud after conversion and select it. Comparing the coordinate data of the 2 points, we will find that the values of the XY coordinates have been transposed. Hi everyone! This video will show you how to use the enclosed volume calculation feature. Select a point cloud to measure its enclosed volume. Click the Edit tab and select Triangulation. In the pop-up window, select Surface Triangular Mesh. Enter a value for the sampling interval. The smaller the value, the higher the modeling accuracy, but the longer it takes. First, set the value to 0.1 and click OK. Then, you can see the generated model under the Model tab. Here, check the model only. The effect looks quite smooth. Next, set the value to 0.9 and click OK. The effect is relatively rough. After generating the model, you can fill the holes by clicking Fill Holes. In the pop-up menu, the default max length is 0, meaning all holes will be filled. Click OK to finish the setting. Click Enclose Volume to pop up the measurement results. This is our introduction to the enclosed volume calculation feature. See you next time. Hi everyone! This video will show you how to use the triangulation and contours features. Select the target point cloud. The first part is about creating a surface triangulation mesh. Click the Edit tab and select Triangulation. For flat objects like the mountain in this example, select the 10 option and set a value for the filling threshold. This means filling holes whose distances are less than the preset threshold. Select 0 by default. Then you can see the completed model. The second part is about creating contours. Select a point cloud, click the Edit tab, and select Contours. In the menu, set the grid size, minimum and maximum height, contour interval, and minimum number of vertices. Then click Preview to view the effect. You can see that there are some unwanted contour lines. In the option of the minimum number of vertices, you can increase the value to filter out unwanted vertices. In the Display Settings option below, you can set the contour line style. Click Preview to see the result. If everything is okay, click Save to generate contours. This is our introduction to the triangulation and contours features. See you next time. Hi everyone! This video will show you how to use the grid's volume calculation feature. Select a point cloud to measure its grid volume. Click the Edit tab and select Grid's Volume. In the menu, select a projection plane. Here, select the Z-axis as an example. Confirm the plane position. Hover the mouse over the plane to be measured, and the current coordinates will be displayed on location in the lower right corner. In this demo, enter -0.55 for the plane position to confirm the starting plane. In the section of Empty Region Calculation Method, choose the desired calculation method. Usually, Interpolate is chosen to take an average. You can leave other parameters as default or change them as needed. Click Calculation to display the calculation results. You can see that the pile surface is covered by countless cubes. It calculates an average value in this way. You can also try other calculation methods to see the effects. If you don't need exact calculations, adjust the step parameter to get a rough value. Click Export Report to export the calculation results as a Word document. The above is our introduction to the grid's volume feature. See you next time.
Artec, Ray 2.
Welcome to Matterport's fall release. Insights meets imagination. Let's dive into our new automations and enhanced property insights that turn 3D virtual tours into must-have marketing sidekicks for real estate agents. Using just one digital twin, you instantly get accurate measurements, info-packed, easy-to-follow reports, and now comprehensive property descriptions that automatically write themselves. Bonus points, it all imports directly into the MLS. Our simple one-click tools not only automate your tedious tasks, they also remove bigger problems that stand between you and making the sale. Like clutter. Now, with the click of a button, you can instantly reveal the potential of that messy garage. Provide buyers with a blank slate to see how their furniture might fit. Or give them the move-in day experience before they even get the keys. No more hiding messes or moving furniture. Matterport takes on the heavy lifting of selling homes for you. But of course we didn't stop there. We can also help once that property is sold. For contractors, building and property managers, and designers, we're making it even easier to streamline your work. You can now merge individual models into one digital twin. Watch this team scan of a manufacturing plant all snap together. Or go upward by combining the floors of a building. Even refresh a previously scanned space like redesigned rooms in a hotel. And don't worry, everything associated with your spaces like tags, notes, and metadata seamlessly transfer to your merged model, ensuring all of your documentation is brought along as your space grows. Now let's talk about capture. Our new Field Tags feature allows you to add your on-site observations and tags as you scan, which become part of the final digital twin. This saves you the hassle of going back to the job site a second or third time, just to document the same details, also saving you time and money. In fact, soon we'll make it possible to go back in time and see through walls to the mechanical, electrical, and plumbing. It's all part of Matterport's next chapter, where we're transforming your ideas into a new reality where insights meets imagination.
Matterport's reality capture is revolutionizing design and construction management across every project phase throughout global portfolios. It all begins with 3D capture. Our groundbreaking Pro 3 LiDAR camera allows you to create photorealistic 3D digital twins and achieve precise, high-density scanning in record time. And one-click file exports including CAD, BIM, and E57 point clouds enable seamless workflow integration with software you already use like Autodesk and Procore. Instantly sync with your existing platforms to problem solve in real time and collaborate from any device. Matterport's end-to-end solution provides peace of mind as a record of conditions before and after a project is complete. Industry leaders across design and construction management are turning to Matterport to stay on time and on budget from anywhere in the world.
Introducing the FJD model, the ultimate solution for making point cloud easy to use. Our product supports data collected from various devices like handheld scanners, airborne scanners, car-mounted scanners, and static scanners. It's also compatible with popular point cloud data formats such as LOS, PLY, PTS, and E57. Our software efficiently processes point cloud data, enhancing its quality and usability. It simplifies data exploration and organization, ensuring accuracy and ease of use. With advanced algorithms, it enables precise rendering and correction of point cloud data. Additionally, it offers automated classification for efficient data analysis and management. FJD model also integrates various industry-specific applications such as urban planning, forestry, mining, and robot mapping. With just the click of a button, our software enables you to extract vector contour lines from point cloud data, making it easier than ever to get the information you need. Our software also supports two types of volume calculation: stockpile volume calculation and enclosed volume calculation, giving you the flexibility to choose the method that best suits your needs. But perhaps the most exciting feature of our software is its ability to easily edit forestry data. With FJD model, you can extract vital information such as single tree location, tree height, and crown width with ease. These attributes can be batch extracted and used to create reports that provide valuable insights into forest surveying, management, and planning. Experience the power of FJD model and make point cloud easy to use today.
Want a more immersive and detailed point cloud view? Explore the new image fusion feature in FJD model. Enjoy enriched detail and take a virtual tour with the fusion of point cloud and panoramic images. Display your preferred view, point cloud or image. Upgrade to an immersive point cloud experience now.
In this video, I'm going to show you exactly how to use the new FJD Trion P1 LiDAR scanner. So first up is you'll turn on the scanner and also the camera. Okay, the default settings of the camera is normally correct. So from there, you take your controller and you have to connect to the Wi-Fi of the scanner. So you'll go into your phone settings, Wi-Fi settings, and you wait until you see the FJD Wi-Fi. You're in it, the password is FJD Trion P1, all small caps, and you join the network. Once the network is joined, you'll go on to the FJD Trion Scan app, and then you'll add the device. You'll select P1. You can say always allow, and now you just simply follow the steps. So I'm gonna say next step, and it picks up the scanner. So now we're ready to scan. For this training, we are in an auditorium where we need to do a scan so that they can use the point cloud data for renovations. So we are going to do 2 scans. The reason for that is we're going to scan the inside of the building, because in Trion model, there's different settings for inside versus outside scans. So we're first going to do the inside, and then we're going to start a new scan and go outside. On the outside of the building, we've already established GCPs, which we're also going to show you how to collect in order to establish control. Let's start. So the scanner needs to be on a stable surface so that it can finish the initializing process. So on our app, we're going to select scan. We're going to enter the project name, auditorium inside. You're going to select OK. It's initializing, so you keep the device still. So that's why it's always better to keep it on a flat and stable surface. Okay, once it's initialized, the camera will automatically start rolling. You will also see on the application there on the top hand side, there's the camera with the green circle. That means that the video is in progress. So for the auditorium, we're going to start on the inside where there's normally the most features. So we're going to walk between the chairs. Okay, when you get to the middle, the range is about 40 meters, so we know we are receiving enough range. So I'm going to make a 360 turn. At a steady pace. Okay, so we are currently scanning floors. So normally what you want to do is you want the center of the scanner actually pointing towards your point of interest. So if you are scanning something that's 30 meters high, you would typically try and point it to the middle of your target so that you get the most effective scanning range. So I'm just going to do a walk around this floor before we go up to scan the second and the third floor. Typically, you would like to keep the segments of your scans within 15 minutes. This just means that you do not have to do multiple measures when processing your data. So we have finished collecting the first part of our data, which was the inside of the auditorium. Next up is the outside. So you will see that we have placed multiple ground control points, which we also measured in with a GNSS receiver. As we start the scan and we come by one of the GCPs, we're also going to collect that with our scanner. Okay, so we're gonna say scan, let's say that's okay. The project name, we're gonna say auditorium outside. And press OK. So again, we're placing it on a stable surface for the initializing process. Okay, so once our scan preview comes up, we know that we're ready to scan. So I'm gonna turn to face the building. So with the P1, the algorithm is very agile. So I can actually go up, I can go down to make sure that I get all the features that I want, and move down in terms of your point of interest, if you're close to your building. Okay, so I'm gonna continue that. I'm gonna walk around the building, and when I get to a GCP, I'm going to measure that in with the Tron scanner as well. So when you come to a GCP, all you have to do is come down. You'll see on the base plate, there's a cross. You place that in the middle of your GCP, and then on your screen, you see the target or the crosshair button. You press it, and you say collect control point. And that you will do with each GCP. Once you've collected it, you can pick up again and continue with your scan. So when you're done with your scan, you press complete and your data saves. So now you're ready to take your data, as well as your GNSS data of the GCPs, back to the office and put everything into Tron model to do your processing.
In this video, we are going to look at how to scan a stockpile for 3D volumetric calculation. In front of me is an FJD Trion LiDAR scanner. You can have this scanner in 3 configurations. You can have it as it looks right now in front of me. We can integrate it with a camera, which allows you to do point cloud colorization. We can also put this on a backpack and also put it with a GNSS receiver. This allows us to do RTK registration on the point cloud. For this scan, we're going to use the FJD scanner as it is. To start the scan, I have set up my scanner. I've attached my 2 batteries and also attached the cable from the logger to the scanner. Once the scanner is on, you will be able to see the scanner's Wi-Fi network. Once this is visible, connect to the Wi-Fi network. The Wi-Fi of the scanner is this one that has FJS1 at the beginning. Select the Wi-Fi and then key in the password. The password is FJD Trion S1, all small letters. Select connect. Once it's connected, go to your browser. When you go to your browser, input the IP address of the scanner. The IP address of the scanner is 10.42.0.1. We are now connected to the scanner. Select the middle icon to create a project for your scan. Key in your project's name, then select OK. This will start the initialization process. To see that the scanner has initialized properly, look on the LED light on the scanner. This will flash red and green while the initialization process is taking place. When the initialization process is complete, this will just flash green. From the LED indication, the initialization process is now complete. I can now pick up my scanner and start with my scanning of the stockpile. So what I'm going to do now is scan the stockpile. I will scan the bottom of the stockpile and also the top, and then close off where I've started off. The scanner has a range of 120 meters, so I'll be able to scan the stockpile even from a bit of a distance. Okay, we've also placed some ground control points. This will allow us to do a coordinate transformation on the point cloud after the scan is complete. Let's now proceed with the scan. So we have now done the scan with the scanner as it is. We will now do this with the RTK integration. So we have set up our scanner with the RTK module. We usually use the RTK module if we have to scan large areas. This is because it's a SLAM scanner. This means that simultaneous localization and mapping. And over a long distance, this can introduce some drift. So RTK helps minimize this drift. So let us proceed with scanning our stockpile with the RTK integration connected. We have now completed the scan with the RTK antenna integration with the scanner. We will now save our data and compare it with the first scan.